programming or thread programming. So whatever the program threads we are going to discuss here, that particular thread is with respect to the Aneka threads, how it is being implemented. Okay, so first we'll go with what do you mean by thread programming. So before and we are going, the agenda of this particular module is first we are going to discuss with respect to the introduction to thread programming, and then we are going to discuss about the parallel computing with threads, how it is achieved, the parallel computing, and how the programming applications we are going to do programming the applications using the threads. So the last two part which you are going to have is in this particular module is domain decomposition and functional decomposition. Okay, so next before we start with the introduction to programming, so let us see that what do you mean by concurrent programming. So when you start talking about your concurrent programming, what do you mean by concurrent programming is the first thing. Now when you are doing the parallelization, so your concurrent programming is also referred as throughput computing. So when you talk about the throughput is nothing but what? Throughput is nothing but the amount of work done per unit amount of time. So within the stipulated or given period of time, how much work you have been done. So now in this one, so in the throughput computing, what will happen? So it mainly focus on delivery of high volume of computation. Okay, so whatever the delivery of high volume of computation is to be given, so it will be focusing on that one mainly. So in the form of what it is going to focus? So it is going to focus in the form of the transactions. So your throughput computing is nothing but what? Your throughput computing is nothing but which is going to focus on delivery of high volume of computation in the form of transactions. So these things you have been already studied in your database as a rule, that is atomicity, commit, isolation, and durability. So that will come again here in the future. So you should be familiar with those terminologies also when we discuss about the transaction processing. So when you start talking about the transaction processing, so your acid rules matters there. So you should have the thorough knowledge of the acid rule, how it is going to work. What do you mean by atomicity? What do you mean by isolation? What do you mean by commit? What do you mean by durability? So just before going for the before I start that particular topic, you just go and revise that particular topic which you have studied in your database management system. Okay, so now with the advancement of multiple system, okay, what will happen? So it was possible to deliver a high throughput computation. So we are going to have the technology which is going to have multi-core technologies. So when you are going to have the multi-core technologies, so it was possible to deliver a high throughput computation, okay, on a single computer system also. So with the with the advancement of the multi-core technologies, so we can achieve the performance in a single system itself. Now throughput can be discussed with respect to two aspects. Okay, whatever the amount of work we are given with respect to the time, so that can be discussed with respect to two different aspects. So the two different aspects which we can discuss is one is multiprocessing, other is multi-threading. So with the two aspects which we have to discuss to have the throughput of the system, that is performance of the system, is one is through the multiprocessing, other is through the multi-threading. Now first comes the question, what do you mean by multiprocessing? Okay, so just I give a brief overview to come to the multiprocessing, that's it, nothing else. So when you talk about the multiprocessing, so multiprocessing is nothing but what? So multiprocessing is nothing but the execution of multiple programs within a single machine. So the layman's definition is it is nothing but what? So it is going to have the execution of multiple programs in a single machine. So when you are going to have the multiple programs in the multiprocessing, so it is going to have the multiple processing units. So what do you mean by multiple processing units? So that means processing units means what? CPU. So in a single system, you are going to have multiple CPUs will be there. So now multiprocessing, it is nothing but what? So the inside a single system, you are going to have the multiple CPUs. Each CPU is going to perform individual job. Okay, so that the multiple programs which you are going to have, it will be executing parallelly. So that is execution of multiple programs in a single machine. So now when it comes to the multi-threading, okay, multi-threading, when it comes, multi-threading is nothing but what? Multiple instruction streams are running within a single program. You are going to have the single program. Within that particular single program, you are going to run a multiple instruction stream. Okay. So now when it comes to the parallelization, so how we are going to achieve the parallelism on a single machine computation? is the next question. So when you start, before going to the parallelism in Aneka thread, so we have to discuss how the parallelism is going to work in a single machine computation. Okay. So when it comes to the parallelism, what do you mean by parallelism? So parallelism, why we have to use that one? Why we have to go for parallelization of the parallelization of my work? So because the word parallelism deals with what? It is nothing but a technique used to improve the performance of the computer. It's a layman's definition, right? So when you talk generally, so when you are going to have the parallelism, so parallelism, what it is going to tell? The parallelism is going to tell you that, so it is nothing but a technique. It is nothing but a technique which is used to improve the performance of a computer. Okay. So before going for parallelization, so I want to put an overview what you have been studied in your CO, I think. So have you heard of Flint's taxonomy? Flint's taxonomy in your organization? Okay. Anyone has heard that one? Being some part of the organization subject, you are going to come across the word Flint's taxonomy. So in that particular Flint's taxonomy existed. So before the Flint's taxonomy comes, parallelism was the technique which was used to achieve the performance. Once the Flint's taxonomy according to architecture, it is defined. So it is basically categorized into 4 types. Okay, it is basically categorized into 4 types. So this is not part of your syllabus. Okay, so this is for your only understanding of the further chapters. So when you talk about the Flint's taxonomy, so you're going to have 4 different types. So that is nothing but your single instruction, single stream, single data, single instruction stream, multiple data, multiple instruction, single data, multiple instruction, multiple data. So this is how it has been categorized. So when you're going with the Flint's taxonomy, it's going to categorize into SISD, SIMD, MISD, and then MIMD. So now, once the multiprocessing existed, as the definition tells that, so multiprocessing is nothing but what? It's the use of multiple processing unit within a single machine. So now once it came into existence, it gave to the several architectures. So it gains a interest and gave birth to several parallel architecture. So what I have been told now, that is the parallel architecture which they have defined is classified into 4 types according to the Flint's taxonomy. So that is your single instruction, single data, single instruction stream, multiple data, multiple instruction, single data, multiple instruction, multiple data. So that is not as part of your syllabus. You should have a knowledge of that one. Okay. So if you are going for IS studies, these are the things which you should know. So now, one of the main important distinctions which you are going to make is further this particular multiprocessing system which you are going to have. So it's further classified into 2 types. One is your symmetric processing unit, symmetric processing system. Another is asymmetric processing system. So now, when you're talking about the symmetric processing system, your symmetric processing system is nothing but what? It's also a type of the multiprocessing only. So here what will happen? So here 2 or more identical processors are connected to a single shared memory. So when you are going to have the symmetric processing, symmetric as the name suggests that, so 2 or more identical processors. So inside inside your single system, 2 cores will be there. 2 cores which are there. So those 2 cores are connected to a single shared memory. Those 2 processors are connected to a single shared memory, and it will be working on that particular single shared memory where the data is kept. So it's having all, it's even this particular symmetric multiprocessing system will be having all its input and output devices. So now when you talk about the symmetric processing, so whatever the OS you are going to have installed in that particular type of system, the scheduling, what it is going to have, it is a self-scheduling. Okay, so in your symmetric processing, multiprocessing, the scheduling which you are going to have is a self-scheduling. But when it comes to the asymmetric multiprocessing, so as the title indicates that your asymmetric multiprocessing involves the concurrent use of different processing units that are specialized to perform different functions. So you are going to have the different functional units, processing units will be there. Different functional units is going to work parallelly, and different functional unit is going to perform different function. Okay, different processing units is going to perform the different function. So mainly, if you take the asymmetric multiple processing, so it is going to run whatever the task you are going to have, that will be run with the help of the OS. So in the asymmetric multiple processing, so that particular that particular whatever the task you are going to give, the task which are giving to be executed, which are to be executed, will be scheduled by the operating system. So operating system will schedule this particular process. Okay, so there you are going to have two different types of terminologies. One is your master, other is your slave. Always, if you take the master, so always the master runs the task of the OS. So if you have the OS, if you have the privilege of the if you have the system user or system calls if you want to make, so your master runs the task of the OS. So whatever the task the OS has to run, that particular task will be run by the master. Now, if you are going for asymmetric multiple processing, so it is basically used in assigning specific tasks to CPU. Okay, so that particular what way you are going to have multiple processing unit, so it will decide which task has to be given to which processing unit. So your master is going to decide that which slave has to be given to which processing unit, so that that particular work will be completed fast. It has to be also check that whether any dependency is there between these two processes also. If there is dependency, how have to schedule that particular system, that particular process to a processing unit, so that the performance can be achieved. So now, when it comes to this one, so next, when it comes to symmetrical multiple processing, so it is features whatever you are going to have. It is use of similar or identical processing units to share the computation load. Okay, as I told you now. So now other examples which you are going to have is non-uniform memory access and the clustered multiprocessing. Clustered multiprocessing is nothing but what? Cluster means what? Group of node. If we talk about the cluster, cluster is nothing but the group of node. So now group of node are combined together and they are working, and they are going to have the job done for that node. So it is when you are defining a specific architecture. Okay, when you are defining a specific architecture for accessing a shared memory between the processor, and we are going to combine all these computers together, and we are going to see all these combined together as a single virtual computer. That is what the cluster multiprocessing is going to tell all about. So you don't have the it is going to define a specific architecture for accessing a shared memory. So this particular clustered multiple processing, what it is going to do is, it is going to define a specific architecture. That means what type of architecture you require, whether you require the architecture of single instruction, single data, or single instruction, multiple data, or multiple instruction, single data, or multiple instruction, multiple data. So now, depending upon that particular type of architecture which you require, the specific architecture will be used by accessing the shared memory between the processors. Now, whatever the whenever you are going to have the shared memory concept in your together, so that are combined together. All these computers are combined together. Along it, all these systems are connected through the same shared memory, and they are working as a single virtual computer. So even though it is a multiple computers which are there, so now it is working as a single unit. Even the multiple systems are working as a single unit. So as a user perspective, I am going to see that those particular processing unit which you are going to have as a single virtual computer. So now these are the two different techniques. So that is symmetric and asymmetric multiple processing, which will be used normally to increase the performance of commodity computer hardware. Okay, so when you are going to have the performance of the commodity increase the performance of the commodity computers, we are going to make use of the symmetric multiple processing and asymmetric multiple processing. Now, apart from these two things, there are another processing units which came into existence, which is that one. That particular processing unit is called as graphical processing unit. So now, which is the de facto processor? So which is this particular type of processing unit is an example of your asymmetric processing. So when your asymmetric processing, which you are going to have, Whereas your multi-core technology is the latest evolution of symmetric multiprocessing. So if you're going to have this particular technology, so if, whereas um, multi-core technology is the latest evolution of multi-core technology. Okay. So now, so when it comes to the parallelism for single machine system, you can see is so how this particular thing is connected. So you can see it is a single CPU die. So you can see this one. This one will be a single CPU die. So in that one, multiple core are there. So each individual core 1, core 2, core 3 are CPUs, individual CPU, which is there inside a single die. So now each processing unit, this is processing unit 1, core 1 is a processing unit 1, core 2 is a processing unit 2, core N is a processing unit 3. Now, before I discuss this one, I have to tell something which is why we have to go with that particular technology only. Why multiprocessor has gained the importance when you are going to have the parallelism architecture. So when you are going to have the if you take about the system, so if you want to increase the performance of the system, one thing which you can have is we can increase the frequency of operation. So you have in the market that you are going to have 1.5 gigahertz of fun by processor of P3 1.4 gigahertz, P3 1.5 gigahertz, P3 2.4 gigahertz. So what that means? Can anyone tell the answer? What do you mean by that 2.4 gigahertz? What is that frequency corresponds to? Can anyone give the answer? What that frequency corresponds to? If any processor is defined with some frequency, what that is going to tell about all about. If I'm going to have that particular frequency as frequency is 2.4 gigahertz, what it tells. So if you how the frequency and time are related, so your time is nothing but inverse of the frequency. Okay, your time t is equal to 1 by f. So where is t is 1 by f. So it is given by 1.2.4 into 10 raised to minus 9. Okay, 10 raised to 9. Okay, so when you give this one, 1.1 by 2.4 is 1.0 to 0.5 into 10 raised to minus 9. Now, what that particular 0.59 ns nanosecond implies with respect to the frequency there. So that particular 0.5 nanoseconds implies that for each instruction to execute, it will take 0.5 nanoseconds of time. Okay, so that means if the more number of instructions are there, it will take more amount of time. Depends upon the program which you are going to run. Okay, now initially what happened? Initially they were increasing the frequency. So whenever they are increasing the frequency, obviously the consumption time of the instruction to run will be reduced. But what has happened is if you are going with the increase in the frequency, so now increasing the frequency is nothing but what? Frequency, when you increase the frequency, it has to switch the state from 0 to 1, because when you talk about the computer will understand only two languages. That is only one language, that is binary language, and it will understand only two values, which is 0 and 1. So now this 0 and 1, when it comes to the miniaturization, it is going to be stored in transistor. Okay, so when it is going to be transistor, some point of the time you have to convert, one zeros has to be converted to one has to convert it to 0. So that means your transistor is switching the state from on to off to on and on. So when it is switching its operation from on to off to on, if more number of frequency has to be achieved, more amount of transistor has to be introduced into the system. If the more transistor are involved, the number of switching actions of the transistor will also become more, because there are n number of zeros and ones will be there. To have this n number of zeros and ones to accommodate, you require n number of transistor. Now, when n number of transistors are working, when it is some transistor will be changing from 0 to 1, some will be changing from 1 to 0. So it has to represent 1 and 0. That will be internally represented with respect to the transistor. Now, when the transistor is working, obviously what will happen? The transistor is going to consume, dissipate the power. And even the transistor has to work means what? It has to consume the power. Now, when the more number of transistors are involved there, the amount of power dissipation will also become more. So if the amount of power dissipation also becomes more, what is the next limitations which you're going to have? The next limitations which you're going to have is the power consumption, power heat dissipation reduction, and how to heat dissipation we have to look after, and how to cool that particular heat I have to look after. So this is the problem which they have faced when they are increasing the frequency. So now, when this particular frequency was increasing, so they come to conclusion that if you go on increasing the frequency, then we can end up with a problem of cooling. So in 2004, what happened is they gone with the technology. They want to end the frequency scaling. That means they don't want to scale your computer with respect to the frequency. So they will end that one 2004. So after 2004, your core dual core system starts into existence. So that means inside your single system, the multiple core they are started introducing. Now, so if you go with the architecture of the computer, if you go with the architecture of your computer, so there you can see that core 1, so each individual processing unit, from the figure you can see it here now. So from the core 1, it is going to have the cache L1. Okay. So now you keep in your mind that whenever in the interview they may ask you the question, where the level L1 you are going to have the you are seen in the system. They are going to have the cache like L1 system, L2 system, L3 system. Okay, L3, L1 cache, L2 cache, L3 cache. Okay. Now, normally your L1 cache resides inside a processor. Your L1 cache normally resides inside the processor. So what the cache holds? Can anyone give the answer? What the cache holds? What is the importance of cache in your processor? If I introduce the cache, what is the advantage of having the cache there? If I don't introduce the cache, what will happen? If I introduce the cache, what will happen? Can anyone give the answer? You know or don't know, that's it, nothing else. We'll move further if you don't know. So if you have the cache, what the cache holds? Cache holds the recently executed instruction. Now, how the memory hierarchy goes? When you start. So now, when you start executing the program, so what will happen is, so first the program looks that particular program to be executed in the cache. So if the cache is not there, okay. So if I take this particular thing, so for example, if you take, if you have the memory hierarchy, okay, if you take the memory hierarchy, so normally what will happen here? So here, what will happen here? 1 minute. Just I will enlarge into the show. So in this one, what will happen here is whenever the processor start executing. So if you take the processor, so first when it came to the hierarchy of the cache. So first, if you take the cache, so initially, if you take the hierarchy of the register, first it will be the register, next it will be cache, next it will be primary memory. So next it will be secondary memory, which you are going to have. Okay. So now when the processor wants to execute the instruction, first it will look into the register. If it is not there, next it is going to look here. So next, if the data is not in the cache, next it is going to look into the primary memory, whether that particular data is there in this particular memory. Now, again, if it is not there, it has to look into this particular memory and it has to start executing. So now, if the first access it has to take is, the first access has to be from the secondary memory only. The first access has to be from the secondary memory only. So very first first access will be late only. So now once the processing starts, what has happened? It will be frequently executing. So once the frequently executed instructions will be stored in the cache itself. So that's why the processing becomes faster when you introduce the cache. Okay, so it will keep the cache will keep the recently executed instruction, but there is limitation in the cache. What? The size. The size of the cache is small, so it can hold only limited limited amount of space is there. So now when it comes to the architecture, so we are going to have the this particular core. So you are going to have core 1, core 2, core n. So each individual processing unit or CPU will be having its own cache L1, one cache L2, L1. So now this particular cache is going to be accessed through memory, shared memory. So now after having through the shared memory, which you are going to have, so next it is going to look for the cache 2. So here cache first level is there here, second level is there here. So if you see that one, even in the cache you are going to have, if you take the cache, so you are going to have this L1 cache and register. This will be inside your processor. This will be inside your processor. Okay, this register and L1 cache both will be residing inside your processor. So apart from this one, you can have the L2 cache, you can have the L3 cache. After L3 cache, you are going to have the primary memory and the secondary memory. So this is how the hierarchy of the memory goes. So if it go with the access time, so access time will be in the upward direction. That means first the processor is going to see the data in the register. Next, if the data is not there in the register, it is going to look into the memory location, which is specified by the cache. Then if the data is not there in the L1 cache, it will look into the L2 cache. If the data is not there in the L2 cache, it will look into the L3 cache. If the data is not there in the L3 cache, it is going to look into the primary memory. If the data is not there in the primary memory, it is going to look into the secondary memory. So that's how the hierarchy goes. So now when you are going to have this particular thing, so this is the your shared memory, wherever all these CPU are sharing this particular memory. So when you are going to have share this memory, all this shared memory is connected to the cache which is outside, which is L2 cache. If you take the dual core system, how the core will be there according to this one. So if you take this particular system, if the core is there, how is there? So it is going to have the single die. So inside the die, dual core, that means two core are there. So let it be core 1, core 2. So these two will be having its own L1 cache, and these two is shared to a common shared memory. So it is shared address space, common shared address space will be there. On top of this one, it is going to have the L1 cache. Okay, L2 cache. So on top of this one, it is going to have the L2 cache. So if you have the dual core, it is going to have two cores in a single die. So if you have the quad core, it's going to have 4 cores inside. If you have the octa core, it's going to have 8 core inside. Okay, quad is 2 core, octa core is 8 core, which you are going to have. Okay, so next, once you have this one, so this depends upon the core n, number of cores which have been designed to run that, to improve the performance of the system. So now all these things is combined together, and there is making a single die. That is, that particular CPU is having the single die, and from there you are going to connect to the primary memory. So this is your RAM. Okay, this is your RAM. So where it is connected to the RAM. Okay, this is how the hierarchy, how it will be represented in your multi-core processor. So now when it comes to the multi-core processor, so when you talk about the instruction level parallelism, so if you take the multitasking and multi-threading, so if you start talking about your multitasking and multi-threading, so multitasking and multi-threading can be implemented on top of the computer hardware itself. So on top of the computer hardware, that is constituted of a single processor and a single core. But it became common practice with the introduction of the multi-core technology. Okay, so in this case, who is going to provide you the illusion that which process has to be given to which core. Somebody should be there to tell that this particular work is less or this particular work is more. This particular work has to be provided to this particular core. So in this case, what will happen? The operating system will give the illusion of concurrent execution by interleaving the execution of instructions of different processes and different threads within the same process. So this is also the case in multi-core or process system, since the number of threads or process is higher than the number of processor or cores. So when you are going with a multi-processor or multi-core system, so if you take the number of process or threads, the process and threads will be created by the operating system. But operating system will not be knowing that how many number of cores are there. Okay, so just it wants to create the threads, number of threads. So it is going to create the threads or the number of process. So and then it will be allocated into different cores in time division. That is, it may be using the round robin scheduling also, or depending upon the task which you're going to have, it may have the priority based scheduling also, or it may be having first come first serve scheduling also. But it will be time quantum will be given between those two. So all of you have seen that one. If you take any of the system, okay. So if you take any of the system, you are going to have the task manager here. Okay, you are going to have the task manager. So now this is the application which is running in the foreground. Okay, so in the foreground, these are some of the applications which are running. So I am running my PDF presentation. I am running my Paint. I'm going to run my Teams here. This is for foreground. But there are a number of processes which will be running at the background. There are a number of processes which will be running in the background. So you can see here, some notifications came in. So now to display that notification, some process should be running at the background. So now where those processes will be residing inside your processor. So it will be running in the background, right? So these are the processes which will be running in the background. So when you go to the process, so there will be a number of processes which will be running in the background. So you can see the list of the number of background processes which are running. Okay, so there are a number of processes which may be running. So depending upon you can see that show process from all users. So that means if the number of users are more, so it has to show the process from all the users. Okay, so that you can have the control of all the how many users are there, how many processes are running at the background. So if you want to improve the performance, you just look into the background process and delete the process which are not required by you at particular instance. So if you do that one, that also increasing the performance of the system. If you remove the background process. Okay. So next, when it comes to the parallelization, so how the programming applications with threads. So why you have to go with a thread? So if before going for a thread, I should know what is a process. Okay, so what do you mean by process? A process is nothing but a programming execution. So if you take the definition of the process, a process is nothing but a program in execution. So when you are going to have the program in execution, okay, so the program in execution, so what it contains, what that particular process is all about. So if you are running an application, for example, as I told you in the application. So if I take application, for example, Control Alt F, okay. So start task manager. So if you take this particular application is there. So some application is here. So now what it is showing here, this is nothing but what? This application, this particular terms which are running here, status which is running, this particular application is nothing but the runtime image of the application. That means there are many applications which are there in the system, but only some applications are running. So that is nothing but a process is nothing but the runtime image of an application. So here it is running. So even in the process, if you take, there are a number of applications which are running at the background. You can see there, Accelerate is there, Adobe Collab is there, Attend LX is there. So I have connected my writing pad is there. So to look after the writing pad and whatever I'm going to write on the writing pad, it should be displayed on the screen. For that one, some process should be there. So it is not displayed here, right? That particular drivers, that particular process which is controlling your writing pad is not shown here, but it will be shown in the process. But it will be shown in the process. You can see it here. So you can go and see the process. In that particular process, you can have, so you can what are the so I have here you can see. So you can see that vacuum tablet is what I am using. So this particular process is running in the background. So if you delete this particular process, what will happen? I'm not able to write the contents on my tab, which will be reflecting on the screen. Okay, so it will happen there, but it is running in the background because it is not high. It is not treated as the main application which has to be run. So now Windows login is running, Windows script is running. So some sound volume has to be run. It is running. So all this process will be running in the background. So these are nothing but the image. It is nothing but the running image of an application. So now when it comes to the thread is nothing but what? A thread identifies a single flow of execution. So by logical sequence of instructions, we can have the single sequence, which we mean a sequence of instructions that has been designed to be executed one after the other. So a thread is nothing but what? So a thread identifies a single control flow. So what it represents the logical sequence of instructions within a process. So you have the process. A process is nothing but a program in execution. So now when you start talking about the thread, a thread is nothing but what? A thread is a part of execution within the process. It identifies a single control flow because different book is going to give a different definition. So whatever the definition we are going to give it here, it is according to the textbook, what has been prescribed by you for you in your cloud computing. So according to the definition of the thread, it is going to tell that, so the thread identifies a single control flow. Okay. So what it suggests, it is a logical sequence of instruction within a process. That means what has to be run one after the other, which program has to run one after the other. Okay. So by giving the logical sequence of instruction, so what it is going to do, by having the logical sequence of instruction, you should know that which instruction has to run first and which instruction has to run next. So that means each instruction is going to run one after the other. Each instruction is going to run one after the other. So now whenever you are taking the operating system, so some of the operating system is going to support multi-threading. So when it is supporting multi-threading, so what is the what is the functionality of operating system there? So operating system that supports multi-threading has to identify the threads, which are the minimum building blocks for expressing running code. Okay. So whatever the operating system that is going to be provided for your multi-threading purpose, so it has to look that it is used as a minimum blocks for expressing running and code. So now when you talk about the process, okay, so as of seeing all the definition of the threads, so if you see the thread, so each process contains at least one thread. Okay, so each process contains one thread. That means one flow of execution is there. One single control flow will be there when you talk about the process. If you talk about the process, what will be there? So normally, if you take the process, okay, if you take the process, so what the process consists of? A process may be having the data segment, a process stack segment, stack segment. Okay, so a code segment it will be having. It is going to have the stack segment, and it is going to have the heap. Okay, so in the heap, what it is going to store is, it is going to store the dynamically allocated memory. So if you take any process will be having 4 blocks. One is your data segment will be there, code segment will be there, stack will be there, heap will be there. Okay. Now, when you talk about the thread, so thread will be having its own individual register and stack. So individual register and stack will be there in the thread, but not data and code segment. Okay, it doesn't have the code and data segment. So it will be stack and registers only can be shared. So if you take the threads, stack data and the register contents can be shared. So that's what it is going to have here. Okay. So next, when it comes to the threads, okay. So when you take the thread, so when you take the process, a process in generally it can have only one thread, or it can have multiple threads. Okay. So as I told you that, So it is nothing but a single concept which you are going to have. So if you take the process, inside the process you can have a number of threads. Okay, so this may be thread 1, so this may be thread 2, this may be thread 3, so this may be thread 4. Okay, so like this it is going to run. So even if you are not creating a number of thread, it is a process. The process will has to control the flow. One flow it has to go, control flow. So this will become one single thread at that time. Okay, so all the threads will be having its own code memory and data memory, but it is going to share register and stack. Okay, so and then even if you take the memory location, which is the heap dynamic memory allocation, even the memory allocation is different for different threads which you are going to have. So why I am telling this one is, this is very much important if you are going for your higher studies like GATE. If you are writing the GATE exams, these questions are mandatory with respect to the thread. How the flow of the thread, what are the different components of the thread, what it is going to share normally. So always all the threads is going to share the same address space. Okay, all of you know, I think. So now when it comes to the thread in the multitasking environment, the operating system assigns different time slices for each process and it leaves their execution. As you know that when it comes to the operating system point of view, each and individual process will be allocated some time depending upon the type of the scheduling. So if you take the first come first serve scheduling, so whatever the first process is coming, that will be done first, and the next process which will be coming, that will be started next. Now this is how the process is going to schedule. Okay, with the help of the scheduling in the multitasking environment, the operating system itself will assign different time slices for each process and interleaves their execution. Okay, so now when you are going to have the context switch, the another term which you are going to have in your context switching, what do you mean by context switch? The context switch is nothing but what? It is similar to the some work is given for section 6A CR. The CR will be working in the HOD's chamber. So now in the HOD's chamber is they are going to work. So in the meantime, the CR from the 6B section will come and tell that the teacher has given the high priority work. I want this particular work to be completed. So now what the 6A student has to give? The 6A student has to leave that particular system. When he is leaving that particular system, what she has to do or he has to do? He has to save where up to the work which has been completed. That means whatever the work is completed, he has to save up to that particular work and he has to release the system to the 6B student. So now your 6A is one process, 6B is one process. So now we are stopping the process which is carried out by 6A and we are releasing that particular resource to 6B. And this particular process is called as context switch, if you understand with respect to the story. So what it means, the context switch is nothing but what? The process of temporarily stopping the execution of one process. That means the process of temporarily stopping the execution of one process. When it is stopping the process, what I need to do, I have to save all the information in the registers and in the general state of the CPU, so that in order to work later, I have to restore all to the normal again. And replacing with what? In replacing with the information related to the another process is called as context switch. So this context switch is very much important when you are designing the operating system or when you are doing with respect to the cloud computing. So context switching is a must. So it is nothing but what? The process of replacing, stopping the execution of the current running process by saving the contents of all the and replacing it with the other process. Okay, replacing with the other process is called as context switching. Okay, so the operation is generally what? It is demanding. So now when you are doing the multi-threading, so normally when you are doing the multi-threading is basically going to minimize the latency. It's going to reduce the minimize the latency imposed by context switch. So when you are going with the multi-threading, what it is going to do, the time, what do you mean by latency? The latency is the time where the first process releases the resources and the second process acquires the resources. The time gap which you are going to have between these two actions, that is releasing the resource and acquiring the resource, that particular period is called as latency. So if the performance has to be more, what I need to do, the latency period should be less. That means, as I told the analogy, 6-day student, 6P CR, as it will be a 6-day student is working in one system. So when the 6P students comes with higher priority, so if he has to work, then the 6A students, what he has to do, he has to save all the work which has been done till that time. Then it has to be released to the 6B students immediately, so that the 6A students should not tell that I have some other work, I have to do this one, I will not release this particular work. Then the performance will be dropped at that time. So as soon as the request comes from the higher priority job, higher priority process, the lower priority process has to release all the resources to the higher priority process. So that is nothing but the latency. The period between the releasing the resources and acquiring the resources by the other process is called as latency. So if the latency is less, obviously the performance of the system will be less. Performance of the system will be more. So by minimizing the latency imposed by context switch, so it is going to allow the execution of multiple tasks in a single lighter fashion. Okay. So here the state represents the execution of the thread is minimal compared to the one described above. So now, if we take this one, so this is just an overview of relationship between threads and process. So if you take the process, within that particular process, you are going to have a number of threads. So it is going to have 1, 2, 3, 4 threads are there. One thread will be main thread. So now, when you take the threads, so you can see that, so each thread will be having the program counter. So the main thread will be having the program counter. That particular program counter will be shared by all the other threads. What the program counter holds, the program counter holds the next instruction which has to be executed. The program counter holds the next instruction which has to be executed. Now, all these threads, you can see from the figure, from the main thread, thread 1, thread 2, all these thread is going to share the same memory. All these threads, it is going to share the same shared memory when it is accessing, or shared address space, which you are going to tell. So your main thread is nothing but the process. So the process, inside that particular process, main thread will be there. It is going to create the child threads, which are going to have all these threads is going to share this common instruction program counter. And so the execution timeline is depends upon the thread. So some thread may complete its work earlier. Some you can see that thread one, this particular thread, the first thread is going, second thread, the first child thread is going to complete its task earlier. Second, it is going to take more time, and third, it is going to take less time compared to the second thread. So it is running individually across the system. And when you talk about the multi-core system, each individual thread will be given to the each individual multiple core. Okay, so that is what it is going to work it about. So this is how the relationship between thread and the process is going to work. So in the tomorrow's next class, we will discuss about what are the different advantages of the thread. Okay, and we'll start with the thread APIs, which will be used for your Aneka. So anybody having any doubt with respect to this one now? Anybody having any doubt? So if you have any doubt, you can ask. So anybody having any doubt? Okay. So if you don't have any doubt, so just go